In this lecture, we are going to walk through some rough code that I wrote in order to download some of the data that we'll be using in this course. So I just want to remind you that when you see code in a plain text editor, that means I'm looking at code from the code repository. If I'm looking at code in a Colab notebook, that means I'm not in the course repository. So just keep that in mind if you ever get lost looking for code. I also want to remind you that we'll be working mostly with CSV files in this course. So if you don't care about how we got the data, note that this code is not necessary to understand the rest of this course, since we'll be just using CSVs. Okay, so the first file we want to look at is called getdata.py. First, we start by importing yfinance and OS. Note that if you don't yet have yfinance installed, you can install it the usual way using pip, by using the command pip install yfinance. Next, we have a list of stock tickers for companies in the S&P 500. I got this list from the Kaggle repository, which I will show you later. However, not all of these companies could be found by the yfinance API. This is not a big issue for us, since we'll only ever look at a few stocks at any single moment in this course. Next, we append the symbol SPY, which is the symbol for the S&P 500 index. Next, I create a folder called Data, which is where we will store our downloaded data. Next, we have a loop that looks at all the symbols in our symbols list one by one. Inside this loop, we check whether or not a CSV file already exists for our symbol in the data folder. If it doesn't, then we proceed. Next, we call the function yf.download to download stock data for the current symbol. I've used an arbitrary start date of January 1st, 2010 and an arbitrary end date of December 31st, 2018. This is mostly arbitrary. 2018 was a long time ago at this point, but I don't think including more data would have been useful for anything that we are going to do. A few dates I did want to capture were the Google and Apple stock splits, which both happened in 2014. You'll see why those events are important later on in this section. Now, recall I said earlier that not all of the symbols above could be found by the yfinance API. So when we get back our data frame, we want to check its size. If the size is greater than 0, then we save the data frame. In the second loop in this script, I loop through each CSV I saved and delete any file which has less than 10 lines. Now, obviously I could have just combined these two loops together. However, this is a very rough script, and I never actually ran this code as it is. I actually used the IPython REPL, so I was copying and pasting code around. So if you want to modify this to suit your needs, you can feel free to do so. The next file we're going to look at is called append.py. You might wonder, why did I previously save each data frame in a separate CSV rather than just combining them all into the same CSV? Well, the reason is, as you'll see later, they all have the exact same column names and dates. Therefore, we wouldn't want to combine the CSVs at that point and be confused about which rows belong to which stock. What we would like to do before combining the data is to have a name column that tells us which stock that row of data refers to, and that's what this script does. So first we import pandas and the glob function. Next, we get all the file paths for all the CSVs in the data folder. Next, I instantiate a variable called fulldf to none, and this is the variable that will store our data frame as we accumulate data from each of the CSVs. Next, we enter a loop to loop through all the CSVs. Inside this loop, we load in the current CSV by calling pd.readCSV. Next, we determine which symbol the CSV refers to by parsing the symbol from the file name. To do this, we first split the file path on the slash, which is used to remove the folder name, which is data. Next, we split on the dot to remove the file extension, which is CSV. Next, we create a new column called name, and we assign it the value symbol, which we just obtained. This will assign the same value to every row in the current data frame. Next, we check whether fulldf is none. If it is, then we can just assign fulldf to be the current data frame. Otherwise, we call the append function, passing in the current data frame df, and assign the result to fulldf. We pass in the argument ignore index, since every data frame we load in will have the same index, which is 0 up to however many rows there are. Finally, we save the full DF data frame to a CSV called sp500full.csv. Now, what we just did is probably overkill, since most likely we will not need all of the nearly 500 stocks that we just downloaded. In order to make things more manageable, we have another similar script called append_small.py. In this file, we import the random module, and we repeat our big list of S&P 500 stock tickers. Next, we have a set called small symbols, which consists of a few stocks that I'll be using in this course, along with a few others from different industries. The reason I wanted to do this is because clearly I'm biased. As a tech person, it's kind of a given that I'm going to choose things like Apple, Google, IBM, and Starbucks. So the point of this is to choose a few stocks from other industries that are hopefully uncorrelated with the stocks that I was predisposed to choose. By the way, you'll learn why being uncorrelated is useful later on in this course. So anyway, since I do want a few more stocks to work with the help of the random module, I sample 100 more stocks from our symbols list. If there are duplicates with our small symbols list, they will disappear in the next step. So the next step is to convert our sample into a set and then do a union of our two sets. As you know, sets can only have unique items, so any duplicates are now gone. Next, we have a loop which stacks all of the data frames from our chosen stocks together in exactly the same way we discussed previously. This time, we save the final data frame to a file called sp500sub.csv. Alright, so that's how I generated the data that we'll be using in this course. Thanks for listening, and I'll see you in the next lecture.